Hi everybody, let's talk about the last few problems, and I'm going to do a few examples from there, show you how to do it. So your note taking will be really helpful, especially when you go to do the problems that you need to do. Okay? So the first problem we want to do is the one right before you. And so what I want you to do is read the problem, the data and the questions you have to answer, and then I'll show you how you can do this. So the first thing I did was I found the minimum and the maximum in the data table. Excuse me. And then I divided the table up in a couple of ways. One way I did it was I said 1100 is close to 1,000, 2800 is close to 3,000. And so I made my classes all of equal size of 400, and that's nice numbers. Or you could do it like we did at the beginning of chapter 2, where you take 2840 minus 1106, and you find the class width, which is 346 approximately, and then you add that each time until you get all the classes. I don't really care how you do it. You need to do it one way and get it correct, and then you want to go from there. Okay? So I'm going to kind of fill out the rest of this where I'm making my frequency distribution, so then I can draw a histogram. What you'll notice is that with the histograms, the distributions, that even if I use the technical way to do it that the textbook gave us in chapter 2, I still end up with the same frequency distribution. The only difference is the labels are going to be different. Therefore, I'm just going to use this one over here because the labels are a little bit easier to do. Okay, so now I'm going to make the histogram. You should do that too. And then ask yourself the question, is it reasonable to assume that the lifespan is normally distributed? And so there's the histogram. So what do you think? Do you think that this distribution is normally distributed looking at the histogram? And the answer to question A would be yes. And the reason I would say yes is my distribution, it's not, although it's not perfectly symmetric, it's nearly symmetric. It's unimodal, which means it has one peak. It looks like the mean is in the middle. Mean in the middle. And therefore, I would assume this is a normal distribution. So that takes us to question 2, which says, find the mean and standard, find the mean and standard deviation of our sample. And so all I'm going to do that is I'm going to use my calculator to find a weighted mean. And if you'll remember, and I'm going to do it with this first table, it would be the same with the second table. But to find the mean and standard deviation from the table, you would have to do a weighted mean using the midpoints. So this is all the way from chapter 2. And don't forget you can use your lists. So I'm going to do that. You should do it as well. And then we'll take a peek at that. So as you can see in the video, what I've done is I have found the mean and standard deviation. I've done it 2 ways. The one way I did it is I did it as a weighted mean using the table, using the midpoints and then the frequencies. And the other way I did it is I used the data, the actual data that was given in the problem. Now, either one of those is correct, and based on what you see here. The data one is probably more correct, and we probably want to use it since we actually have the data. But if you didn't have the data, you can see that the weighted means values are not very far off from the actual data. So even though there's error, it still gives us a pretty good estimate, and that would be okay. So that takes us to the last question, which says, compare the mean and the standard deviation of your sample with those of the manufacturer's claim. So the manufacturer's claim was that the mean lifespan was 2,000 hours and the standard deviation was 250 hours. So based on our test, all right, our test, the claim was 2,000 and 250, and based on our sample test, whether we're using the table values or the actual data, what we notice is that the manufacturer's claim for the mean average life bulb seems to be a little bit high, and his variance, his standard deviation, how much it varies, seems to be quite a bit lower, because it looks like they vary by almost 450 hours, which is quite a bit more spread out. And so you would write a couple of sentences to answer that, and that would be the end of the question. I encourage you to look at the example in the textbook that goes with this problem as well, and that example is example, I believe I don't see it anywhere, so you don't have to worry about it. Probably example 2 would be the most helpful. Okay. So read this problem. I just want to put out that all you want to do is match each value with the letters A, B, C, D on the given graph of the standard normal, and find the z-score that corresponds to each value, and then check your answers to A and C in the back of the book and determine whether any of the values are unusual. And so what they have is they have something here that says that the company's manufactures piston rings for cars. The diameters of the piston rings are normally distributed with a mean of 93 millimeters and a standard deviation of 0.005. The inside diameters of the 4 rings selected at random are 93.014, 018, 004, and 92.994. And so the question is are any of these piston ring values unusual? And so I'll get the normal curves so you can see them here in just a sec. So as you look at this normal curve, what you will see is that the curve they had listed A, B, C, D on the axis below the normal curve. The mean in the problem was 93.01 millimeters. The standard deviation was 0.005 millimeters. Therefore, when I look at this diagram, the mean is right in the middle. And then 0.005 is standard deviation. And so that kind of marks these out a little bit like that if I follow where it's concave down using the information I know about the curve. So the question is, which letters correspond to these numbers? Well, if I take 93.01 and I subtract 0.005, then one standard deviation below is 93.005. 2 standard deviations below is 93.000. And so, and then I can go above as well. I can add the standard deviation, and so 1 above is 93.015, and 2 above is 93.020. And so if I look at these, this is close to 2 standard deviations above. And which letter is close to 2 standard deviations above? It's letter D. 93.014 is close to only 1 standard deviation above, so that should be letter C. 93.004 is close to 1 standard deviation below, so that will be letter B. And then finally, This is close to 93, so that's letter A, which is 2 standard deviations below. In fact, it's in between. And so that gives us a good idea of what these letters correspond to. Okay? And that's all you have to do on that type of problem. And finally, to finish up this lesson, there are 2 kinds of problems, but they change just a little bit. What happens is in your textbook, they tell you, and I'm going to tell you the same thing right now, that area is the same as probability. Since the area under the normal curve is 1, and probability has to be between 0 and 1, the area under the normal curve is actually a probability. It's not just an area. And so because of that, they give you a set of problems where they ask you to find the probability. But you do all those problems in the same way we did problems 18 through 40, which is just find the area, and then area under a normal curve equals probability. And so the 2 types of problems you'll see are written as I have written 1 and 2 right here. So let's do number 1. I see the area, the probability that I want is between 1 standard deviation below and 0, those 2 standard deviations. So therefore, I know that I can go look those values up in the table, or if I wish, I can just do a normal CDF, and what I fill in is the left bound, -1, the right bound, 0, the mean, 0, and the standard deviation, 1. And when I do that, I should get approximately a probability of 0.34. And I know that from the 68, 95, 97, 99.97 rule. And so, but from the calculator, it's actually a probability of 0.3413, or if you wish, 34.13%. And so this next problem, they actually write it as a probability statement. So what I often like to do is just draw a picture so I can see it. Oh, it goes from -1.85 to the right because it's greater. And so therefore, on the calculator, I need to use positive infinity. So this becomes a normal CDF, and the left bound is -1.85. The right bound is positive infinity, which I'll do as 99,999. And then the mean is 0 and the standard deviation 1. And if you enter those in the calculator, you are going to get 9678, so a probability of 0.9678, which is also the area. And that's how you do the final 2 problems. So what I would like for you to do is, on your assignment, I would like for you to do finish problems 42 through 62, all of which use skills you know, and now you've seen problems of each type. So thanks a lot. We'll talk to you later.